you got to have, something where um, you don't have a linear term. You're missing a linear term up there. We can solve that by square roots. With factoring we've worked on that throughout the second semester. Factoring, you have all three terms up there. You have your A term, you have your B term, and you have your C term. Now, with the factoring there, sometimes the linear term's not there, sometimes the constant's not there, and we dealt with that. We can factor. But the problems I've been giving you with factoring, they've been very specific. They've all been factorable. Now, what I'm about to give you here today, they're not all factorable. And when they're not all factorable, we have to have a backup. And that's what we're going to look at with the quadratic formula. The quadratic formula takes everybody. The quadratic formula has no favorites, it takes everybody. Factoring, though, takes favorites. It can only work with certain things in there. So that's what we're going to look at here today is the square roots. You have to have a linear term missing. Factoring, you have to have very specific A, B's, and C's to work out. With the good old quadratic formula today, it doesn't matter. Quadratic formula will work when this is working, will work when factoring is working, it will work no matter what. So let's get into it. Let's do some work with it today, and then we'll move on and get you guys some practice out with that. It looks worse than it is, so let's go. First thing is, though, you always got to make sure you are in our good old standard form. If you're not in standard form, rearrange it, okay? Is it me or is it monkey or stuffy or something? All right. It's married smoothly. So you gotta make sure in standard. That goes without saying. Now the next thing is, well, I'm gonna throw it up here. How we derive the quadratic formula, we're not gonna have time to get to. I'm just gonna throw the formula out here, talk about using it. So it looks worse than it is. Okay, the variable that we're using here, x equals, the variable x equals, all right, negative b. That b value is coming from right here, just like we did with factoring. Plus or minus. Why plus or minus? Well, how many solutions do we typically get in quadratics? Yeah, we typically get 2. The square root of quadratics square roots, right? Square root of b squared minus 4 times a times c. All of that divided by 2 times a. Now, that is the thing to remember, okay? That is the thing for us to get used to using. I don't expect you to have it memorized by the end of today, but we're going to do some more practice today, tomorrow, Wednesday, come back after spring break. I got some more practice built in for us to get comfortable with it, okay? But that's what the quadratic formula looks like. Somehow this thing right here gets rearranged, manipulated, solved out for x, so that it becomes that. Okay. So let's use it. Okay. It's just like geometry where you have our formulas. Where area of a triangle is what? 1/2 base times height. We plug it in, we work it out. It's gonna be the same thing today. You got your calculators, right? Let's go do this. Let's take that first one. Is it in standard form? Nope. Let's rearrange. 5x squared. Okay. What do we got to do now? Minus 8x, right? Minus 7, right? Equals 0. Cool. We're there. Now, you've got, right at the top of the page, you got your formula. You've got your A, B, and C value. We're going to plug them into the respective spots. Just like you'd be using a geometry formula. Slowly plug them into the respective spots. So as we plug them into the respective spots, the very first part says what? Negative b. So what are we going to have there? Negative what? Negative 8. So negative.
That's already
correct. So you got to watch out for those dang negatives. Absolutely. So Tyler and Jacalos pointed out here, we're going to eventually create a positive 8, aren't we? Okay. Now I'm going to write the whole thing out one at a time, but you got to watch out for these dang negatives. Plus or minus the square root of. Now it says b squared. B squared. What is b squared? Negative 8. Do parentheses matter?
Yes.
Absolutely, right? We talked about the squaring back with Pythagorean theorem and the radicals. Same deal's happening. Minus 4. And it says what? Times A, times C, times A. What do we say A is? What do we say C is? Negative 7, right? All of that divided by 2 times what? 5. 2 times A, 2 times 5. That's our very first step. Can you correctly plug in the values? You've been doing that idea since like 5th and 6th grade when you start learning how to plug in values for 5 plus x. It's just the next step here. Okay, as I hear calculators getting ready to go, let's get ready to do that. Let's clean this thing up. We're doing an order of operations. Now, you've already told me right here 2 negatives are going to make that a positive. This is where my calculator, you got to be great at it. Underneath the square root, you're not going to type in the square root. You're going to type in everything underneath the square root. So let's go to that. What's it say? Negative parentheses, negative 8 squared. And then minus 4 times what? 5 times what? Negative 7, right? So at this point, we hit enter. Underneath the square root is going to become what? 204. All that back to the calculator, because what is 2 times 5? Okay, we don't need a calculator, do we? Yeah, we know that one, don't we? Okay. Now it's our first time through. It might be like a little whatever, because we've never done this before. But we have done evaluating expressions. We've done evaluating expressions forever. All we did was just do order of operations right here with our calculator. Now, we're right here at this kind of ugly thing. Screw root 204. Go back to August. Go off to the side. Can you do anything with the screw root 204? Simplify that radical for me. We've done this work for months at this point. Okay? Take 204 off to the side. Can you simplify that radical? 204 goes someplace. I'm pretty sure it does. Okay, 204 goes somewhere. You're going to bring in everything that we've been working with throughout this entire school year on. You see a radical, can you simplify it? I try not to like keep adding on brand new things. There's options we have to. So I like to try to come back to something that's familiar. 204 becomes, I heard, yeah, 4 and 51. Now 4 is perfect, isn't it? So as I heard from Tyler and Milana just now, 2 squared 51. Like we've done that. We did that with square roots. We've done it, or sorry, Pythagorean theorem, I should say. All divided by 10, isn't it? Now, if you're like me and I'm running out of room here, I'm going to lead this into question 2. We're not going to do question 2. We're going to use the room over there, okay? All right. We've never done that. Who cares? Whatever. Think back to now dividing radicals. Can I do anything up here with any type of reducing? Can I reduce anything up there? Yeah, I see that right there. Yeah, she's saying, she's doing this, so she's giving a peace sign. Okay, she's saying I can reduce by 2, right? She's saying I can reduce by 2, right? Okay, now one small caveat here. I've got 3 things going on though. This 10 is dividing into 2 and also dividing into what? 8. You can only reduce if all 3 things can be reduced at the same time. That's the thing you gotta watch out for. So can we reduce 8, 2, and 10 all at the same time? Yeah, we can. Reduce it. If this was 8, 3, and 10, can I reduce 8, 3, and 10 at the same time? So then don't do it, we're done. But 8, 2, and 10 can reduce by 2. What is that? 4, 1, and 5. So I'm going to drag this off to the side because I'm clearly running out of room. Okay, so pause. I'm going to drag this off to the side. I'm running out of room. So what is that? 4 plus or minus the square root of 51 all over what? 5. Do I need a 1 out front? No. I can put the 1 out there. Right. Now, it looks ugly, but that is our answer. Now, let me talk about that answer before you're like, I don't know what the heck he's got there. Give me a moment. Okay. Now, we've done this again before. Pause, don't write this down. Where have we done this before? When we're solving radicals, solving by square roots, I should say. Square root of 48. Square root of 48 is plus or minus 4 square root of 3, and we left it right here with our two solutions, right? Positive 4 root of 3 and negative 4 root of 3, right? Same idea. Only difference is we got a little bit more going on. So I left it as just kind of one big term there. But you're going to see it written like this. I'm lazy. I tend to leave it like that. But we also split that apart. What do I mean by split it apart? You'll see this as a solution as well. So that answer is fine. You can leave like that. Another way we can redo this is rewriting it so that we have it written as our two solutions a little bit more obviously seen. 4 plus the square root of 51 over 5. And what's the other one going to look like? 4 minus the square root of 51 over 5. Both of those are my answers. Hiding in there, they're just pulled apart. Just like that plus or minus the 4 square root of 30, 4 square root of 3 I just had. 4 root of 3, negative 4 root of 3. So it's the same thing. Plus or minus 5. 5, negative 5. And as we get into the next part of algebra with quadratics, this is what we call our irrational solutions. With that square root of 51 hiding there, not hiding, it's in plain sight. These are what we're going to call our irrational solutions. And in the quadratic formula, that allows you to solve these out. We can never do this by factoring. Factoring, you're not going to be able to solve these out because these are irrational solutions. Okay. So this answer is cool. Breaking up and giving me these two answers, that's cool as well. All right. All right, that's one. Let's go do the second one. All right, what do you want to do? Pick one, 3 or 4? 3? Cool. I don't care because it doesn't matter to me. Let's go do 3. We'll take 3 and we'll lead into question 4 then. All right, 3. What do we got to do first? It's not set to 0. We got to do what? Set to 0 by doing what? Rearranging and adding what? Yep, adding 8n. Rearranging and adding 8n. And the nice thing about the quadratic formula takes anybody. I typically like having my lead coefficients be positive, but you don't have to on the quadratic formula. So what I mean by that negative 4, I'm going to leave it as negative 4 and square. I like in factoring to have that be positive. I'm not going to worry about it. Quadratic formula, it's a machine. Plug it in, let's work it out. We're good to go. It's set to 0 now. Let's go to our formula. We're not using the variable x this time. We're using the variable n. Okay, what's it say at the top of your paper? Negative b. So negative what? Oh, negative b is negative 8, correct? Okay. Plus or minus the square root of. It says b squared. So 8 squared minus 4. What do we lock in a as? A is what? Negative 4. What do we lock in c as? 117. Absolutely. All that divided by what? 2 times, yep, negative 4. Now, would you like to try to factor this with 117 out there? No. That's where the quadratic formula is nice, because your calculator is your buddy there. All right, let's go. Let's go clean this thing up. Negative 8, there's nothing there. But underneath that square root, that's where your calculator is your friend. All right, 8 squared minus 4 times what? Negative 4 times what? 117. Calculator says 1936. Yep. All divided by 2 times negative 4. 2 times negative 4 is negative 8. That 1936 is going to get a special name in just a moment. That b squared minus 4ac gets a special name. I'll talk about here after this problem.
The discriminant.
Okay? Now, let's deal with that square root. That's a large number. I don't know my perfect squares after a certain amount. Before I just go start doing my factor tree there, take that 1936, see if it's a perfect square. Yeah. I mean, for myself, I know 289 is 17. You may not. I expect you know 225 is 15. But I would take 1936, see if it is a perfect square, save yourself some time. It is a perfect square. So I'm going to now run out of room, drag that over here to the side. So negative 8 plus or minus 44 all over what? So the difference between this one and the first one we did is that square root is gone, isn't it? What this tells me is we have what we say is a rational solution, not an irrational, but a rational. And this also tells me is we could have actually factored this one. It would have been maybe not a fun one to factor, but it could have been factorable because there is no square root remaining. But we're committed. We now have to continue finishing this off. You cannot leave it like that. Once that square root is gone, you have to commit to finishing it, of splitting it up into its two solutions, and give me the two rational solutions now. Okay, what's negative 8 plus 44? Divided by negative 8. Oops, make sure I can write it right. And then go get me the other one. Negative 8 minus 44 divided by negative 8. Once that square root's gone, it's no longer your rational solutions. You are now committed to getting me those two rationals. So let your calculator do the work. Don't let your arithmetic screw you up. Negative 8 plus 44. 36 divided by negative 8. Negative 4.5. I'm fine with that. It's a nice terminating decimal. You can give me negative 4.5. You can give me the fraction. Negative 9 over 2. I don't care. Either one of those. I mean, those are nice numbers. What's my other rational? Negative 8 minus 44 divided by negative 8. So make it 6.5. That answer's cool. Or the fraction. So make it 13 over 2. Or 6.5. Again, either one of those is appropriate. I'm fine with any of those. Okay. Now, the reason why I knew that was going to work out like that is because this dude underneath here, it's 1936 up above. The other one, I forgot what it was, 204 I think it was. That number underneath there, I'm going to now come back to it before I flip to the next page.
Is also
I don't. Which one you say? I don't know if that one. So that number underneath that square root, that b squared minus 4ac that's calculating it, that plays a very big role in a lot of other things. It's going to tie it into the graphs. It's going to talk about the types of solutions for us. Now, unfortunately, we are not going to have time to keep going down this big old rabbit hole of quadratics. You're out with two teachers are. I just don't. Okay, we're already short on time as it is. But we call that the discriminant. Okay? The discriminant is that piece underneath the square root right there. So that discriminant is being calculated as b squared minus 4ac. And if that turns out to be a very specific type of number, it does a lot more to what type of graph we're going to get, what type of solutions we're going to get, and so on. So if I say, hey, what's your discriminant's value? I'm talking about this 204. I'm talking about that 1936 I think we just got. Okay? If it's something else, where it's positive or negative, does something more to our graph and the types of solutions. We're not going to get far into it, but you guys are two teachers well. Flip, let's go. Tyler, give me 1 second there. Shoot. Trying to think which one we just did. I think we're going to do number 5 now. That'll be our last one. And we'll do the next page, the next part. Okay, number 5. Are we ready to go? Or do we have to do something? We have to rearrange. So put it in standard form. No. 8b squared plus 5b minus 11 equals 0. Doesn't it? Okay, might have to fortunately flip it back and forth. And then slowly plug it into the formula. It's all about the formula there. It is a big, powerful formula for you. As you work through more quadratics, next year in Algebra 2, your quadratic formula probably becomes as important as knowing how to factor. Okay, we're using the we're using the variable b. It says it says negative b, negative 5, plus or minus, square root of. It says b squared, so 5 squared, minus 4 times a. What's a? And what's c? There you go. And don't forget, I always have a handful of students that are lazy, not paying attention, they forget that 2a. 2 times a is 2 times 8. Okay? Or they think, hey, I'll remember 2 times 8, and then they don't remember 2 times 8. Okay, calculator time. Go determine that discriminant's value then. 5 squared minus 4. All right, what's a? 8. What's c? Negative 11. Somebody check me. Plus you. Plus you. 377 is what I got to. And 2 times 8 I heard is 16. Now, I always check to see 377, is that perfect square? Is 377 perfect? No, it definitely is not. So, get that ugly thing off my calculator. Now, what did the directions say on this one, though? Does it say simplest radical form? Round to nearest what? 1,000? Thousands it says? Okay. So here's the thing I'm going to do now. I'm done with simplifying radicals. It doesn't ask for it, as you're going to see in Algebra 2. A lot of times with this, they're going to ask you for both. That's why I'm going to get you some practice with both. Okay, here's where we're going to go. Split up into your 2 solutions. Negative 5 plus and negative 5 minus. Okay. My 2 answers I want as rounded to nearest 1,000, he said. I don't care about simplifying these radicals anymore. They might, I don't care. Because what do the directions ask me to do? Round it. Who cares if I'm simplifying 377 and plugging in my calculator or not? I don't. So now go to your calculator and let's plug it in and round it correctly. Now as you type this in, negative 5 plus square root of 377, I like to put that in parentheses, square root of 377, and then close that parentheses, and then divide by 16. As we've talked throughout the school year, you got to make sure you're knowing how to use your calculator properly, how it reads things. Now I'm going to type this in again. I'm going to type it in correctly, talk about what your calculator is doing and not doing. So as I typed that in 2 ways just now, one way is correct, one way is not correct. I got 2 numbers that sound legit at this point. but the top one is done correctly. Your calculator is adding together -5 plus that, and then dividing it by 16. What is your calculator doing on the second row? Your calculator is taking the is taking the square root of 377 divided by 16, whatever that is, and then adding it to -5. You don't want to do that bottom one. You want to add those together first, and then divide by 16. So that's the importance of the parentheses. So get in good habits now. Don't do that bottom one. You better do that top one with those parentheses. Okay. So nearest, what is it? Thousandth? 0 point, what is it? 901. And then go do the bottom one. Yeah. Did you use the negative out front, or did you use the subtracting symbol? Okay, and the last one here, parentheses, -5, and this time we're using minus sign. The square root of 377. Close that parenthesis, divide by 16. -1.526. Somebody else got that? Okay. You know how to use your calculator. You've done everything up to this point algebraically by hand. Cool. You know how to use the calculator. Okay. All right, that's where we pause things. It's all about practice now. You've done 3 of those types. That's about as crazy as that's going to get. Clear out your desk. Pencils and calculators is all you need. Clear out your desk. For the remainder of class here, here's what's going to happen. Attach back your test onto your test. It's been highlighted. Anything that's going to highlight something's wrong, you have an opportunity to fix that highlight. When you've done the highlights, turn it back into the basket. And on the class calendar is an opportunity. Is the assignment for today.